What is up, ladies and gentlemen? Welcome to our 8th lecture for this particular AMAth Crash Course series. So for today, what we will be focusing on is, after our prior discussion on the coordinate geometry of polygons in our 2D graphical environment, we're going to move on to talk about the coordinate geometry of circles. We're going to learn how to draw circles on graphs. We're going to learn the equations of a circle, and we're going to learn how to deal with geometric problems on your x and y axis when we add in a circle in addition to all the other crap that you have seen so far. Right? Right, so for now, let me do a little bit more setup, and I should be ready within the next 1 minute or so. I am still a little bit ill because this is the same day in which I did the previous video, so I will probably sound a little bit weird. It's fine. Okay, we are ready to go. Let us not waste any more time. I would like for today's video to be relatively short. People in the chat are asking, do my students understand what the heck the video thumbnails are? So those of you who are watching right now and who are my students, you know the answer yourself. Alright, let's begin. So for today, we don't really have a lot of particularly nasty details to cover. I would simply like to talk about the various ways you can write the equation of a circle. Then afterwards, we will talk about some different problems where you have a circle and a straight line. For example, how do I know if they don't touch? How do I know if it is a tangent that only contacts the circle in one singular spot? So on and so forth, right? And of course, we will end off the lecture with some practice problems. Due to the relative lack of new content within this topic itself, we will primarily be focusing on practice problems. So let us begin. First of all, the standard form of a circle is always in this particular shape, right? First thing we need to know is that on the right hand side we have the constant r, which is a positive real number, which means we cannot have 0. We can have negative, strictly speaking, but it would be more convenient to restrict it to the positive reals. And of course, you don't expect anything that will give you a math error. For example, the square root of -4. That wouldn't make sense, right? Now the constants over here, a and b, in this case refer to the coordinates of the center of the circle, and of course the r from originally refers to the radius. Now, as a result of the way this formula is created, this equation of the circle, it means that if you have a circle whose center is on the origin itself, 0, 0, then we can expect a and b to both be equal to 0, therefore giving this simplified formula. Right, some examples of circles are given over here. Honestly, these are super straightforward. And of course, if you are watching this and you are my student, then you should have these notes with you in the first place. So I will leave it to you to review these examples by yourself. Now, another way of writing down the equation of a circle is to simply open up all the brackets, right? So we will get this really ugly shape instead. And if you are able to memorize this formula, you could actually just dig out the center and the radius like this. However, this formula is ugly. This formulation isn't intuitive, and nobody likes working with this guy. So I highly recommend that you just try to avoid all of these whenever possible. It's not worth the effort. Now, if you want to convert from one form to another, you can either open up the brackets or you can go back to the bracket shape by using completing the square, right? With two examples given here. At this point, I hope you will pause the video and review the examples by yourself. There are a few other exercises over here, so let us take a look at some. We will take a look at a few basic ones, and then we will try some slightly more awkward ones. So for the first one, for example, this is a triviality because it is already in the bracket shape. So we know for a fact that the center will simply be 5, 3, and that the radius will simply be 4. Alright, of course, given that you're watching this video as a refresher, I am sure that those of you who are looking at part A with me right now are probably just thinking, wow, this is starting off very easily. So for the second one, similarly, it is quite clear that the center will be -1, 0, and the radius will be the square root of 27, alternatively 3 root 3, right? Because, of course, the square root of 27 is equal to the square root of 9 times 3, i.e. the square root of 9 times the square root of 3, in other words, 3 root 3. Of course, in this case, there is one little detail to take note of, which is that we have plus y squared, which of course you can interpret as plus, let's see, plus y minus 0 square. These two formulations are equivalent in value, and of course from here you will see that, the y coordinate is simply going to be 0, right? Very straightforward. So taking a look at a slightly more unpleasant example, let's take a look at part D. Part D, this time round, is already expanded for us. This is not the standard form, this is the general form of a circle, meaning to say we don't have any brackets at all. So when we see something like this, you could either memorize all this trash over here, or you can take matters into your own hands and perform completing the square to force fit it back into a bracket shape. So what we shall do is, of course, you will notice that we have x squared and plus 16x, allowing us to do completing the square in this fashion. Meanwhile, we have y squared and minus 18y, allowing us to do completing the square on y as well, giving us the following result. Last but not least, we will carry over the 120, and the right hand side will remain as 0. You can go on to simplify this by leaving all the brackets on the left and all the numbers on the right, which will therefore give you x plus 8 square plus y minus 9 square equals to 25, i.e. 5 square. And from here, it is clear that the center is -8, 9, and very obviously the radius will be 5. Right? Just as one last example, let's take a look at maybe part G, for example. Right? So part G is a little imbalanced for some reason. There's objects both on the left and the right hand side, but it is not the standard form. So for part G, we will start by moving everything to the left. We should expect to get the following result. Once we have this, then as usual, we shall perform completing the square. Whenever you are doing completing the square, do keep in mind, I know we covered this only way back in the very first video, but do keep in mind that the constant within the bracket can be obtained by taking the coefficient of x and dividing by 2. Right? It's a little faster that way. And don't forget to subtract the imposter. You realize I already made a mistake because I forgot to subtract the imposter on y. After you have found the magic number by dividing by 2, you have to remember to subtract the imposter away, like so. From here, then let's carry over to 41, we'll get 0, and let's see, we should expect this to turn out to be x minus 3 square plus y minus 6 square equals to 2 square. Well, equals to 4, but you get the idea. And from here, we have the center to be 3, 6 with a radius of 2. Right? Now, the next thing we are interested in are problems where we have a line and a circle together. So for example, you could have a situation where they simply want you to find the points of intersection, in which case we recognize the possibility of a circle being cut by a straight line at 2 separate instances. In other words, we will expect simultaneous equations with 2 solutions. So in order for us to solve for the coordinates of the intersection, it's always crucial to remember that as simultaneous equations go, it is very easy for us to perform substitution. The only problem is whether you get careless in the working, because you can see that from this step to this step, there are a lot of different small workings to do. You have a lot of algebraic arithmetic to crunch. So please be careful of that. There is one exercise over here, but it is reasonably simple, so I would not like to spend too much time on this. So they tell us there's a straight line, they gave us the equation. There's a circle, they give us the equation. They want you to show that the intersection points are these two, and hence find the area of the triangle created by the origin and these two intersection points. So what we can do is, let us substitute the straight line. Oh wait, let us start with the straight line and make x the subject by moving away the 33. Then we'll call this equation number 1. Let us substitute equation number 1 into the circle, and this will give us x, which is this guy, x plus 11 square plus y minus 7 square equals to 169. Alright, from here, let's see, of course you can simplify the first bracket, and from here it is simply a matter of opening up all the brackets and moving everything to the left hand side. Why do we move everything to the left hand side? It's simple. It's because you must remember the ideal shape of a quadratic equation is algebra square, algebra, number equals to 0. Once you have this, you can use either method you want, completing the square, quadratic formula, or bracket factorization. In this case, factorization works very well. We should get the following, which implies, of course, that y equals to 2 or 7. Using equation 1, then of course we know that x will be equal to negative 23 or 2 correspondingly. And therefore, the points of intersection will be A, negative 23, 2, and B, 2, 7. And this is what we wanted to show, QED. Right? So from here, of course, I think it is quite obvious, but let me just draw it out for you. These two combine together here, and of course, those two combine together there, right? So once we are done with all this, the last part of the problem asks, can we find the area of triangle OAB? So in this case, there are two options. Option 1 is to use our technique from the previous lecture, right? We can simply use the shoelace strategy, right? We have O, which is 0, 0. We have A, which is negative 23, 2. We have B, which is 2, 7. Don't forget to go back to the starting point, 0, 0. From here, of course, we will be able to crunch all the multiplication out. Given that this shoelace method is from the very most recent video, I will not go through in depth. We should expect negative 161 minus 4 braced together by the chopsticks. Of course, the chopsticks will get rid of the negative sign, and this gives us 165 over 2 square units, and we are done. Now the second method is for you to play smart, right, and try and actually crunch out the area manually. So you can imagine the origin to be here. You can imagine the point A over here, negative 23, 2, not drawn to scale, and you can imagine the point B at 2, 7, let's say over here, right, also not drawn to scale. From here, you will get this funny triangle here, and this leads you to two different sub-methods. The first sub-method is to use the y-axis here to split it up into a triangle on the left, let's call it P, and a triangle on the right, Q. You'll need to find the y-intercept over here, and from there, you can just find the area of P and Q by using half times base times height, then sum it together. The second method, of course, is for you to use trigonometry. If you are able to find the angles, for example, if you can find angle AOB, it will be simple enough for you to use the formula half AB sine C. Now, both of these methods are more tedious than simply using the shoelace strategy, so I do not recommend it. Let me take a look at the chat. We are very busy today. How about if there's a line and a circle? Well, we're moving on to the next section, which is over here. I would like to remind you that way back in the second lecture, we have learned about the quadratic discriminant, and earlier on back then, I have discussed the idea of using it for algebra that contains y squared. Anything with a square sets up the use of the quadratic discriminant b squared minus 4ac. And what happens in the equation of a circle? Well, in the equation of a circle, very obviously we are going to have a y squared. And this therefore ties back into the very second video that we have seen in this crash course series. We will simply be able to use the discriminant after performing substitution. And we will then be able to use the discriminant to determine how many distinct real roots are there. And this will determine the number of intersections between the line and the circle. For example, if I have a circle like this and line is floating above, then after using substitution, I should expect the quadratic discriminant to give me a negative number. Why is it a negative number? Because if it is floating above, then there are no intersections, i.e. the line does not touch the circle, and because there are no intersections, therefore there are no real roots to the simultaneous equations. Let's see, just finished a lesson and I saw this on Twitter. Today is a great day. I'm glad you're having a great day. I would say it's a great day, but if you look at the time on the bottom right, it is now 12:41 AM, so a new day has started, strictly speaking. But this day is not bad so far. So I guess we have that in common. Let's see, there are special names given for lines on circle. Okay, this is not a very important part, but it is good to know. We have certain words that we like to use. I will leave this entire section for you to review by yourself. Make sure to read the whole page together. I have also included for you a diagram at the bottom. Let me scroll down for you to take a look. Now, one important thing I want to talk about before we move on to the last section is there are some circle properties, some geometric properties of circles from eMath that are pretty important. First of all is tangent perpendicular radius. Any tangent will always have one radius that is perpendicular to it. As a reminder, radius means you start from the center and you go towards the circumference. The second thing we need to know is that a diameter always acts as the perpendicular bisector of a chord. Now what does this mean? It means that if we have a chord, i.e. a line that starts from the circumference and ends somewhere else on the circumference, there will always be some diameter, i.e. I pass through the center of the circle and then I go to the two sides. There will always exist this random diameter somewhere that will act as a perpendicular bisector. And because it is a perpendicular bisector, we also need to keep in mind the perpendicular bisector of a chord passes through the center of the circle. Now this is very important because if you just came from my previous video, you will remember we learned how to find perpendicular bisector. Step 1, midpoint theorem by using the average of the x coordinate and the average of the y coordinate. Step 2, because perpendicular lines have their gradients multiplied to give you -1, we can find the gradient of the perpendicular bisector. Step 3, use the gradient and the point and do y minus y coordinate equals to gradient, open bracket x minus x coordinate. This will give you the equation of the line of the circle. And since this line, this bisector, will pass through the center, you can use this equation for simultaneous equations in order to find the location of the center. That is the power of combining today's lecture with, or rather this current lecture with the previous lecture. Alright, we will see some examples of this later. Okay, so there are some exercises given over here. The first exercise is supremely trivial, so you can just take a look at that. The second exercise tells us, okay, can we find out whether this random line will meet the circle at all? Now, meet simply means that I can touch it once, or I can cut it twice. Either way is okay. Now, if it touches once, we would expect the discriminant to be equal to 0. If it cuts 2 times, we expect 2 solutions, i.e. the discriminant will be greater than 0. So let us combine these criteria to get discriminant greater than or equal to 0. So for question 2, we have 2y equals to x minus 1. Obviously, this means x is equal to 2y plus 1. Let's call this equation 1. I will then substitute equation 1 into the circle. And this gives us x squared plus y minus 2 squared to be equal to 4. We will then open up the brackets, giving us 4y squared plus 4y plus 1 plus y squared minus 4y plus 4 equal to 4. And once we are at this stage, things will be very beautiful. we can cancel the 4's here, we can cancel the minus 4y with the plus 4y. And this will simply give us, let's see, let me change it back into dark green. This will simply give us 5y squared plus 1 equals to 0, like so. From here, it is very clear that the discriminant will be b squared minus 4ac, which is negative 20, which is less than 0, and therefore we expect no real roots. And this implies line does not meet the circle. And we are done. As a reminder, always answer to what the question wants. In this case, the question did not want the number of real roots. The question merely wants you to find out, is the line going to touch the circle? So tell them exactly that. Tell them, no, the line does not meet the circle at all. Alright, answer to the question. Let's see, we have a third problem over there. Oh, hey, see you. Right, we have a third problem over here, and this one is actually quite guided, right? Some blanks are given for you, so I will leave this for you to review by yourself as well. And congratulations, we're actually done with all the content for today. So let us take a short break, and then afterwards we will move on to actually try out our hand on some surprisingly difficult exercises. What is up, ladies and gentlemen? Welcome back. Now we will be moving on to the practice questions segment of this particular lecture video. So let us jump straight into it. Alright, so the first problem over here tells us, okay, can you find the center and radius of some random circle? And afterwards show that some specific point is outside the circle and explain why a line will never be a tangent. Extremely interesting stuff. So let us start with the first part. They would like us to find the center and radius of this particular circle over here. So what we're going to do is let us start by, of course, moving everything to the left hand side. We should expect x squared minus 6x plus y squared plus 2y minus 15 equals to 0. From here, we will perform completing the square, i.e. we should get the following. Right, hopefully by this part of our crash course series, you will now be a master at completing the square. We should get this following result over here. And once we are here, of course, if you look at the constant terms, it will go out to be a total of negative 23. So let's move the 23 to the right hand side, and we will keep the algebra on the left. So x minus 3 squared plus y plus 1 squared equals to 23. So from here, we conclude that the center is definitely 3 comma negative 1, and the radius will simply be the square root of 23. And we are done. Now for the second part, they ask, can you show that this particular position is outside the circle? So in order for us to do these kinds of problems, let's think about it geometrically. Say we have a particular circle like that with a center, let's call it G, and a random point, let's call it P1. Let's have a second random point, let's call it P2. Now what we can do is we can actually measure the radius of the circle. Let's call him R. Now you'll notice that for P1, because he is outside the circle, the distance from P1 to G, in other words the line P1G, this line will be greater than the radius R. Similarly, if I have a point inside the circle, P2, then the distance between this particular point and the center, which is P2G, this distance will be lesser than the radius R. Right, so over here, we have P2G, which is lesser than R, and over there, we have P1G, which is greater than R. Therefore, if you want to determine if someone is inside or outside the circle, it suffices to simply compare it to the radius of the circle. So in this case, the distance between 7, 3 and 3, minus 1 will simply be obtained by using Pythagoras theorem. So we'll take x minus x, we will take let's see, y minus y, square them both, and apply the square root. This will actually give you the square root of 32, right? And this square root of 32 is very obviously greater than the square root of 23, i.e. it is greater than the radius, and therefore 7, 3 is outside of the circle, which is what we wanted to prove, QED. Now the last part asks, explain why a line that is in the shape y equals to mx will never be a tangent to the circle. Right, so I want you to imagine the graph of the circle for yourself. We are at 3, negative 1, or let's see, we are at 3, negative 1, like so. We have a pretty big radius, I would say. We have a radius of like square root 23 units. Okay, let me make it more accurate. Right, you can imagine for yourself, square root 23, that's not a small number, right? You can expect the circle to be something like this. So if you have the line y equals to mx, then we have 3 options. Option 1, m is 0, and the line is simply 0. the x-axis. Option 2, m is positive, so we get direct proportion. Option 3, m is negative, so we will go downwards. Do you notice that all three case scenarios are not tangents? We have already cut the circle twice. And why is that the case? It is because the magic point, the origin, is already inside the circle. And when you look at the equation y equals to mx, it means that we have y equals to mx plus 0, i.e. the y-intercept is 0, i.e. I will always pass through 0, 0. As long as we can show that 0, 0 is inside the circle, this is tantamount to saying that the line must always pass into the circle. So that will be our strategy. We simply need to work with, actually showing how the origin 0, 0 is actually stuck in the circle. So how we will go about this is the same as part 2. We will simply have to use Pythagoras theorem to our advantage. So you can imagine for yourself that the distance between the center of the circle, 3, -1, and the origin will simply be as follows. So the distance between origin and 3, -1 is equal to 3 square plus -1 square, and this will give us the square root of 17, which is obviously less than the square root of 23, which is the radius. Therefore, O must be inside the circle. But the line y equals to mx always passes through O, so it is impossible for this line to be a tangent. And this completes the proof. QED. Right, some simple geometric consequences. Alright, now for the next problem, we have question 14. Tells us that there is a line y equals to mx plus 10. It is a tangent to the circle. Right, tangent. So that means if I have y equals to mx plus 10 and I substitute it into the circle, I should get, let's see, x squared plus y squared minus 10 equal to 0. It means that when I perform this substitution, the quadratic equation I get will also only have one contact point, i.e. one x-intercept, i.e. one distinct real root, i.e. discriminant equal to 0. So this is the thinking process. So let us open up the square brackets. We'll have x squared plus m squared, x squared plus 20mx plus 100 minus 10 equal to 0. In other words, we should have m squared plus 1 x squared plus 20mx plus 90 equal to 0. From here, we will be able to say that the discriminant, right, the discriminant will be b squared minus 4ac. When you do b squared minus 4ac, remember to account for the entire coefficient. In other words, b is this whole thing, okay, c is this whole thing, and a is this whole thing, right? So from here we will have b squared minus 4ac, and we say that this is equal to 0 because of this logic from earlier. From here, we will simply open up the brackets. This should give us 400m squared minus 360m squared minus 360 to be equal to 0, i.e. we can rearrange to get 40m squared equals to 360. Therefore, m squared will be equal to 9, implying m is equal to plus minus 3, and we are done. Once we have that, the second problem asks, can you find the point of contact for each value of m found in A? So Right now we have m equals to plus minus 3. Let's say we have m equals to 3. Let's start with the positive case. Then that will mean that y equals to 3x plus 10, and we will substitute y equals to 3x plus 10 into the circle. This should give us x squared plus y squared minus 10 equal to 0. From here, we will go on to open up the brackets. So x squared plus 9x squared plus 60x plus 100 minus 10 equals 0. In other words, we should expect the following result, right? So once we have this particular result, you can actually factorize out the 10, and this will produce for you the following situation, right? I'm not sure if you can see it directly. If not, you can always do the bracket method by using your scientific calculator. And from here, we'll get x equals to negative 3. And since x equals to negative 3, we will have, let's see, we will have to use the original line here, and this will give us y equals to 3x plus 10 equals to 1, i.e. we will intersect at x comma y minus 3 comma 1, and that will be the coordinates of the point of intersection. The same method can be used for m equals to negative 3. I will leave that to you as an exercise for you to do by yourself. Alright, so once we have all of that, let's move on to the next problem. The next problem and the last problem will actually be very difficult. So let's take a look over here. We have this 11 mark behemoth. Now, points A, B, and C have had their coordinates given to us, and we recognize that the chords A, B, and B, C created have the midpoints M and N. The question goes on to say, can you prove, or rather, can you explain why MP and AB are similar? So if we look at MP and AB, you'll recognize that MP comes from the diameter, and AB is this random chord over here. But the thing is, we can simply say that MP, or rather the line that contains MP, is the perpendicular bisector of a chord, and that in itself is the reason, since line passing MP is a diameter. So if you really want to be specific, you can say that the line passing through MP, which is this person over here, is actually the diameter of the circle, and the diameter is always a perpendicular bisector of the chord, which therefore means we will have a perpendicular. And that's all. Super straightforward. So the next thing they say is, can you use the gradient of AB to show that MP has an exact gradient of blah blah blah? So this will actually come from our previous crash course lecture. What we will do is we will start with the gradient of AB, which in this case will be, let's see, y coordinate minus y coordinate over x coordinate minus x coordinate. This will give us the following scenario. Let's see, 4 root 2 minus 9, and therefore the gradient of MP is equal to the negative reciprocal. In other words, we should expect this result. Why is it negative reciprocal? Please remember what we saw in the previous lecture video. It is a negative reciprocal because if you have perpendicular lines with the gradients m1 and m2, that means that m1 multiplied by m2 equals to negative 1, and therefore the second person, the new gradient m2, will be negative 1 divided by m1, the negative of the reciprocal. So reciprocal, of course, just means you swap numerator and denominator, and negative means that I will swap the order on this guy. So this is what we have. The gradient MP, or the gradient of MP, will give me this. Now you will notice, however, that the final answer is completely different. The final answer is all the surds on the numerator. So this is a throwback to our third lecture video of this crash course series, where we learned how to do rationalizing the denominator. So we shall rationalize by multiplying by the conjugate surd, like so. The denominator will hence turn into a square minus b square, and over here we will go on to realize that, hey, this denominator, right, actually turns into a nice number. It turns into 49. Right, it turns into 49. So I can cancel the numerator and the denominator, and this gives us 9 plus 4 root 2 over 7, which is what we wanted to show in the first place, QED. Thereafterwards, they say, hence, show that MP has the equation blah 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 blah. So in order to work this out, what we're going to have to do is, we have the gradient of MP. Now we just need to find a random point. Finding P is obviously impossible, we don't have any information at all, but finding M is easy because this is a perpendicular bisector, if you remember part 1. As a perpendicular bisector, that means it passes through M, the midpoint. So M, we will simply use the midpoint theorem from the previous lecture video. So we shall have 7 over 2, comma, and then over here, let's see, negative 31 minus 4 root 2 over 2, comma. Sorry, bracket. Right, so as a reminder, in order to find the midpoint, if you already have the starting and the ending of the line segment, we can simply take the average of the y coordinates and then the average of the x coordinates. In this case, average referring to the mean, right? So I will add them together and then we will divide by 2. Now once you have this, then we can use the same strategy as always, which is, if you have a straight line, the equation will be y minus the y coordinate equals to the gradient, open bracket, x minus the x coordinate, like so. This goes on to, if you're supposed to be sleeping, go to bed. So this goes on to simplify into, let's see, we shall have y equals to 9 plus 4 root 2 over 7 multiplied by x, and then afterwards we will have, let's see, minus, the 7s will cancel out, so 2, 9 plus 4 root 2, and last but not least, we need to bring the other object, which is the funny bracketed object, right? So I'll bring the whole thing over to the other side, like so. So this is what we will get up to this point. Right, so once I have, actually went on to dig up all of the numbers that we need for the right hand side, right? Because if you look at the final answer, y is by himself alone on the left hand side. What we will see is that we can go on to simplify everything by ourselves. In this case, I almost feel like there's a typo with the question, because right now if it seems like I'm not going to get an integer constant. So perhaps the question is actually incorrect and you will not get a negative 20 over here. Of course, if anybody in the chat is able to find any careless mistake, then please point it out. If not, then I'm just going to work under the assumption that I must have made a typo in the question itself. Ratio, Twitter reference, so true. Don't care, didn't ask, plus ratio. Anyway, so from here, all we need to do is to simplify this result, and it should give us the following formulation. Who is texting me at this hour? Okay, understand. Let's see. Alright, so from here, we will open everything up. We should get the following result. Like this. And of course, once you have this particular scenario, we can combine all the constant terms together, we can combine all the cert terms together, and this will give us the following. So again, I feel like there might have been a typo in the question. It's also entirely possible, of course, that I simply made a careless mistake over here, but in the worst case scenario, all the steps are still correct. So I'm gonna assume that there was a typo in the question. So this will be the equation of MP, right? So now that we have the following result, let me write it down somewhere. Right, so MP will actually be this guy, minus 67 over 2 minus 10 root 2, like so. Alright, now the next part asks, can you find the equation of the line segment NP? NP. Right, so equation of the line segment NP, that will simply be this entire line over here. Right, so how do I find this line? As it turns out, you can simply do the same thing, more or less, right? Because once again, this is a chord, which means we can do the perpendicular bisector trick yet again. So let us start with the midpoint, and we will simply take the average of the x coordinates. So 16 and 7, that gives us 23 over 2. The y coordinates, negative 11 and negative 20, that gives us negative 31 over 2, right? And of course, the gradient of NP will be the negative reciprocal of the gradient of BC. So we'll have negative 1 divided by, and then from here we calculate the gradient by ourselves, like this. Right? So once you have this, you will realize that very nicely the denominator is actually going to just give us probably the easiest possible answer. Is going to give us 1, and therefore we will have negative 1 divided by 1, i.e. we'll just get negative 1. From here, it is easy enough to find NP by doing y minus the y coordinate equals to the gradient x minus the x coordinate, like this. And from here, we can go on to say that we have 23 over 2 minus x, y plus 31 over 2, and therefore y equals to, and then we will move the constant over, and this should give us, let's see, negative x minus 4, and we are done. So this will actually be the equation of NP. Alright? Okay, so once we have this, the last thing is, can you find the coordinates of P, and therefore can you find the equation of the circle? So in this particular situation, what we expect is to do simultaneous, right? So I will sub the equation of NP into the equation of MP. So I will sub this guy into that guy. Therefore, we should get negative x minus 4 equals to 9 plus 4 root 2 over 7x minus 67 over 2 minus 10 root 2. Like so, this is what we will get. So once you have done the substitution, the game plan is going to be as follows. We will first solve for x. Once we have solved for x, the next option, or rather the next choice, the next decision will then be, we'll take the x, we'll sub it into the easier equation. In this case, it will be NP. We will substitute it into there, and from there, we should get the value of y. Once we have this value of y, we can then go on to say that, okay, P is going to be x comma y, and from there, we can choose any point we want, A, B, or C, as long as it's on the circumference. And we will use Pythagoras theorem in order to get the distance between P and the circumference, which of course will be the radius of the circle. From there, we will have the radius and we will have the center, which is P, and since we have the center and radius, it will be easy enough for us to create the standard form of the equation of the circle, right? So that will be the strategy over here. So I will skip the boring steps. You should get x equals to 49 over 4 plus 21 root 2 over 16, like so, right? And therefore y will be equal to the negative of x, which is like that, and then afterwards minus 4, not plus 4. So throw this whole thing into your calculator. You should get a 3SF value. However, since I'm doing the teaching over here, right, I would like to instead leave everything in exact form, right? I'm going to do the more difficult option so that if you really want to try it out for yourself, you at least have something to refer to, right? So because of that, that's why normally in my classes I will end up doing exact form, even if the question doesn't specify it, i.e. you will be allowed to do working to 4 significant figures. Right, so after this we will have negative x minus 4, which should give us negative 63 over 4 minus 21 root 2 over 16. So from here we have p to be 47 over 4 plus 21 over 16 root 2, comma, minus 63 over 4 minus 21 over 16 root 2. Right, once we have this, it will be easy enough for us to find the radius. So the radius will be the distance between p and, let's choose c, just for the heck of it. And this radius will be a little bit on the ugly side because we're gonna have to do Pythagoras with this absolute disaster. So we should get x coordinate minus x coordinate square plus y coordinate minus y coordinate square root the whole thing, like this, right? So in this case it will be no longer that economical to do everything in exact form. So once you are over here, this is a good spot for you to stop using exact form and jump into, you know, just slapping everything into the scientific calculator. That is what we're going to do. So let's see, I'm going to need to type this into the calculator as well, so please sit tight while I feed everything in. Okay, so we'll get 7.0265. In other words, r square will be 49.371. It is possible for you to do this in exact form. However, it will be extremely disgusting and again, probably not worth the effort, not gonna lie. If you decide to do it in exact form, realistically speaking, your teacher will also be a little bit tilted because, bruh, you have to keep in mind that whatever you write in exact form, your teacher is going to have to check as well. So if you want to harass your teacher a little bit, you know, you want to do a little bit of trolling, then of course the option is available to you, right? So if you really want to do it in exact form, you should get the result of, let's see, r squared equals to 3041 plus 84 root 2 over 64, right? Looks like a nightmare, looks like a war crime even. But yes, if you decide to do this for some reason, then you will be correct as well. So now that we have the radius, and therefore we have radius square, and we have the center of the circle, we can conclude that the circle is simply going to be, let's see, x minus x coordinate of the center square plus y minus the y coordinate of the center. Do take note that the double negative will change it into a plus, square equals to radius square, which is 49.371, i.e. 49.4 to 3 significant figures. Alternatively, you can write in the exact form and it will be very terrible. This is what you're going to get. Alright, so that will wrap up this problem. Okay, the last problem is also a bit of a difficult one. We have a circle over here with the center of the circle being given to us, 2, 4. They have also very kindly provided the radius, which is 5 units. Alright. Now they say that the vertical line x equals to 6 cuts the circle at A and B, and afterwards a point C inside the circle and lying on the y-axis is chosen to create the parallelogram OABC. Alright, now the first part of the problem asks, can we find the equation of the circle and then the coordinates of A and B? So in order for us to do this, I need you to recognize that if this line is x equals to 6 and this point here has the x coordinate of 2, then that will mean that the distance between them is simply 4. And that will be helpful in the future, but for now we don't actually need to worry about that so much because they haven't really asked anything about the line yet. All they asked so far is, oh, find the equation of a circle, which is really straightforward because they have already given you the radius over here. So for part 1, we will simply say that I have x minus x coordinate square plus y minus y coordinate square equals to radius square, 25. Boom, we're done. From here, we want to find the coordinates of A and B. Now A and B, now we can look at this line. This line tells us x equals to 6, so I will sub in x equals to 6. This gives us 6 minus 2 square plus y minus 4 square equals to 25. In other words, 4 square plus y square minus 8y plus 4 square equals to 25. From here, we can rearrange the algebra in order to create a quadratic. So in this case, we should expect the following result. Once we have this, we will go on to factorize, which will give us y minus 1, y minus 7 equal to 0. And therefore, y equals to 1 or 7. And obviously, y equals to 1 will be the lower person, A. So A will be, so A will be, let's see, x equals to 6, y equals to 1, and B will be x equals to 6, y equals to 7. And we are done. Alright? So let me write down the equation of the circle and the coordinates of A and B. Part 1 is going to be x minus 2 square plus y minus 4 square equals to 25. And then we have A to be 6, 1 and B to be 6, 7. Alright, now let's clear the right hand side and move on. The next thing they want is find the coordinates of the midpoint of OB, which is called M. They did not join in this picture, so let us add it in by ourselves right now. You can imagine OB having a line like this. Oh wait, I should probably erase all this. You can imagine OB being a green colored line like this with the middle position here. We'll call this M. So they want us to find the midpoint M and therefore use it to find C. So the idea is, if I can find this middle position M, what I can do is I can simply find the instructions to walk from A to M and then repeat the instructions a second time in order to get to C. That's all. So let us find M. In this case, we already know that B is 6, 7, so we can simply use the midpoint theorem from the from the previous video, and say that M will be the average, which will be as follows. Of course, having said that, 6 plus 0 over 2 will simply give us 3, so let us instead have this result. Alright. Afterwards, they say hence find the coordinates of C, so you can ask yourself, A is currently 6, 1, okay, and M is currently 3, 7 over 2. So the journey taken must have been 3 steps backwards, and then afterwards 2.5 steps forwards. So I will simply need to perform this journey a second time, and this will give me the coordinates of C, which in this case will be 0, let's see, 3.5 plus 2.5 is 0.6. And we are done. Right? Always remember for a parallelogram, right? If you have the middle position, I can just do one travel like this, one commute like this, and the second commute in order to get to the opposite corner will be identical. We will learn this more not in A math but in E math, when you learn about the concept of vectors and how we know two vectors are equal and what it means to have equal vectors. Right, so we have C to be 0.6 and we have M to be 3.7/2. Now the third part asks, can we find the area of the parallelogram OABC? Of course, you have two options here. The first is to use shoelace. The second is to simply use the standard formula, which is the length of one side multiplied by the width of the parallelogram. In this case, the width is indicated by x equals to 6. In other words, the distance between this x equals to 6 vertical line and the y-axis must be 6 units. That will be the width. And as for the length, we already know that A is at y equals to 1, right? And B is at y equals to 7. And therefore, the distance between them must be 6. So you could actually just say that the area will be 6 times 6 equals to 36 square units. Alternatively, you can just do the shoelace method. We can start from the origin, 0, 0, and then afterwards we can go anti-clockwise. So A will be 6,1, B will be 6,7, C will be 0,6. Don't forget to go back to the start, 0,0. Now that you have all of this, then we can go on to do all the multiplication. In this case, let's see, we will have 0 times 1, 6 times 7, 6 times 6. This gives us 78. Then afterwards we have 0 times 6, 1 times 6. Let's see, 7 times 0, 6 times 0. So it's just going to be 6, right? Like so. Add in the modulus, the chopsticks, add in the half, and this will also give you 36, which is what we got earlier. Alright? Now the last two parts of this exercise will be creating new circles. So for part 4, they ask, what happens if I take the circle and I reflect across the line y equals to x? What will be the new maximum point? So I need you to recognize how to do reflections. Let's say we have some random s point. Let's call it p, q. There are 3 different ways that we can commonly reflect. The first reflection is across the x-axis, and what this results in is that the y coordinate will be negated. The second possible reflection that is common is to reflect across the y-axis, and this will actually negate the x coordinate. Alright, so it'll be somewhere over here. The last scenario is if I have the diagonal line y equals to x, I can reflect across y equals to x. So when we do reflection across y equals to x, what happens is that the x and y coordinates will swap. Now you can prove this or verify this by yourself in your own time. Since this is a crash course, I will not spend time on the proof of it. Instead, we're just going to assume we already know this. And therefore, the center will simply swap from 2,4 to 4,2. In other words, we should expect x coordinate of 4, y coordinate of 2. Having said that, however, the radius, thankfully, will still be the same. So we can expect a radius of 5, i.e. the right hand side will be 25. Now the question asks, what is the maximum point of this new circle? So you can imagine for yourself a circle. The center is at 4,2 and the radius is 5. So you can travel 5 units up, and this maximum point at the top will be 4,7. So the maximum point will be 4,7. And we are done. Now the last problem is actually slightly easier. They want us to reflect across the line y equals to 6. Now this is an uncommon reflection. So I want you to imagine this is the circle, okay? This is the center, right? And we know that the radius in this case is 5. So you can imagine the maximum point 2,9 over here. Now, what we're going to do is we have this, let's see, oh sorry, x equals 6. We have this horizontal line over here, x equals to 6, just like in the diagram. that is on top, right? And we're going to reflect across this way. The reflection will therefore produce the following result. I think it should be reasonably easy for you to verify that we will do this. So you can imagine what I said at the very beginning. We could actually use the x equals to 6 and the coordinates of the center of the circle to deduce that the distance here will be from x equals to 2, right, from the x coordinate, to x equals to 6. In other words, this distance will be 4. Therefore, this distance will be 4, and when I reflect, that distance will also be 4. However, the height of the center does not change, and therefore we can conclude that the overall journey will be starting from x equals to 2 and then moving forward by 8 units in order to get x equals to 10. So the center will now have x equals to 10, and because the height didn't change, we still have y equals to 4. Now that we have the center, we can answer this question. We will have x minus x coordinate square plus y minus y coordinate square equals to radius square. Thankfully, the radius again didn't change. The radius is still 5. So if the radius is 5, then we can expect to have 25 over here, r squared. This will be the equation of the circle. From here, the question asks, what would the point on the circle closest to the y-axis? So if you look at this diagram we have drawn again, everything is on the right of the y-axis, and therefore the point closest to the y-axis will simply be the leftmost edge. And therefore I will start from the center, which is 10, 4, and then I will travel all the way to the left, which will be 5 units. So 10, 4, travel 5 units to the left, it will be minus 5, i.e. we will get 5, 4. And we are done. So you can actually draw this out by yourself, right? You can imagine I have the circle over here, I have the center, right? And in this case, let's see, the center is 10, 4. In this case, we have 10, 4 as the center. We have a radius of 5, and you want to go as close as possible to the y-axis. Very obviously, it will be this position over here, right? And we will therefore travel 5 units to the left, which gives us 5, 4. The height does not change, and that's why we get the 5, 4 as the answer, as the answer. Alright, so up to this point, this completes all the content we have for today. As I said, this is a relatively short topic. We really just focused on example problems. Alright, so if you have nothing else for me, I have nothing else for you. You are dismissed. Thanks for your time, ladies and gentlemen. This was a pretty stressful day actually. This is the second stream, and they were almost back to back. So I'm really glad to see that we have had an audience for both of the streams actually. That's fantastic. And for those of my students who are still watching, congratulations on making it this far. The last 2 topics for secondary 3 will be trigonometry. I'm going to be honest, I might not even do the trigonometry videos within the next, for example, 7 or 14 days. Because I've already been seeing you all in class, and we have already started teaching trigonometry, or rather revising trigonometry. In other words, there is no urgent need for me to cover those topics on video right now. So just in case this is the last online lecture that we have in a long time, I would like to once again reiterate, thank you all for watching. It's been a great pleasure to actually have all of my friends and students over here join me in these online classes. They will stay up on my YouTube, of course, so you can refer to these crash course videos anytime you would like to have a refresher, right? So yeah, one last time, thank you all for watching. Question in the chat, will there be a circle with circle stuff? Circle intersect with circle? Of course, why not? I simply chose not to cover it in the crash course because I will be covering it in our physical classes. Alright, so I shall end the stream in 1 more minute. Oh yeah, and I should probably say, since the time now is 1:36 a.m. Good night, everybody, and one last time, ladies and gentlemen, thank you for your time. Alright, T4W, and hopefully I will see you guys again in the near future. We will see how it goes.